Okay, good morning, everybody, and welcome to our webinar on 3D digital realities. My name, for those who don't know me, I'm Kieran Kirk. I'm the Operations Director with IMGS, and with me this morning is Andrew Paul. Hi, Andrew. How are you?
Hi, Kieran. How are you? Yeah, I'm
Not
good.
so bad. Andrew is our remote sensing lead and expert in IMGS as well as a few other hats as well. But that's the one you're wearing today, Andrew. You're the yeah, people are just joining, so we're just going to get going. So actually, we have a lot to cover, so I think we'll kick off. So this morning's webinar is on 3D digital realities. We're going to cover this morning 4 areas. Just talk briefly about the Hexagon ecosystem as IMGS. We're a Hexagon partner and have been for over 20 years. Then we talk about the HXDR managed service for digital reality. Then I'll introduce AirDAS Imagine as a product, and then Andrew will give us take his life into his own hands and give us a bit of a live demo. So then we'll see some stuff in AirDAS, and then we'll come back and we'll talk about, as naturally as a FME safe software partner, what FME can do for 3D and digital reality as well. So first off, the Hexagon ecosystem is from sensors to solutions. So Hexagon cover everything from the different sensors, whether aerial, laser scan, mobile, whatever it is, to bring data in, to also being able to consume Hexagon content from the content program where they get it from third parties, and also being able to bring in public information. Hexagon technologies then allow us to do AI and spatial modeling using the Hexagon cloud. And from that, we can produce digital twins, which are mesh, semantic data, enterprise data, which can then be used for software solutions for government, transportation, and defense. So the HXDR managed service, how does that work? Well, it takes in from your sensor, from your camera, it takes in your aerial imagery and your nadar and oblique imagery, and then the HXDR process will actually automatically, through the managed service, generate your land cover classes. So it does 23 land cover. It also then generates per class probabilities for your data to help classify that data, and then it can generate impervious land cover out of the data, and then the other probabilities as well, so that you can then go on and start generating features. So an example of this is the city of Klagenfurt, which was a city in Austria. It's 120 square kilometers, 100,000 inhabitants. There was 5 terabytes of aerial imagery, nadar, and oblique. And with it, they had the goal to quantify and qualify GeoAI results for selected categories against customer feature data. So in it, the data products resulting from the HXDR were the following. So as I said already, we were able to generate the land cover classes and the pair class cover probabilities, also able to auto-generate the digital terrain model and also the digital surface model. And from that, then we are also able to create true ortho photos coming out of the imagery, and then create a digital reality mesh. So this is all auto-generated by the HXDR managed service. So taking the data from the sensor up to the cloud, processing it, and generating these products. And then from that, we're even able to create LOD2 buildings, so a complete building model, and LOD2 trees out of the features. So being able to generate that data automatically through the process. So the organization, if it's a city, if it's a national mapping agency, if it's a utility or telecom who need to produce a 3D data for whatever reason, or their digital reality, can provide the data to the HXDR service, and this is the outputs that they're auto-generated without actually having to do any real kind of involvement or work. So to give you some of the kind of imagery we were seeing, so you can see here the true auto images, but also you can see on the features here the actual heights of the buildings and the trees, which are being generated from the map. You can then see the LOD2 buildings that were auto-generated. So again, any city or council who is looking to have a 3D map of their area, or if you're a telco who wants to be able to do 5G analysis, and you need to need to know what objects are in your way from your towers, having this kind of data, having this kind of detail, means you can do this kind of work. Also, once you've created these kind of models, you can then start using the slope and angle of the buildings to start calculating where you can actually put solar panels. So if you're a city or a county or a utility who's looking at solar panel placement, which is a big push these days to improve green tech, how do you plan that out in the city? Well, actually, once you have that kind of 3D data, you're able to actually do that. And you can also see then you can because you've got footprints of buildings, you can then do spatial analysis of those footprints as well and see the size and information against them. And we can break all that features out into a layer tree so that they can be used in a GIS or in a system for whatever data people want to use. And even here it's in GMedia doing a simple, buffer polygons for each tree based on height. So you can see the width of the tree and the tree cover. And then with that, take that information on and start looking at utility networks and see which utilities are overgrown or which power lines have tree coverage in front of them that's going to cause an issue during a storm. So being able to bring that information in. So to show this system in itself, this is using the Map Enterprise software to visualize the data. So the Hexagon Map Enterprise. So we can see here the 3D mesh of the city, and hopefully it's coming through the webinar. But you see how crisp that imagery is, how fast it's moving, and this is all auto-generated. So no manual process. So literally taking the data from the sensor, processing it through, and then generating this kind of digital reality, and then being able to push that information out. So you can see the nice mesh in the system. You can see the quality of the imagery. You can see, the features, like how the clarity of the cars on the map, and then being able to actually do measurement on that system. So again, here we are measuring the height of the building. So again, if you're a city, if you're a utility, if you're a government agency who are looking at this data, being able to very quickly have a 3D view, whether it's from looking at planning permission for new planning applications for new buildings, whether it's looking at current issues, investigating space, whatever it is that you're needing, then that's in the system to be able to use. So we can see now, if I speed up, that just stopped it. Sorry, it's just pause for a second. So the video is now, you can see as we move in, we can also then put on things like sun, light, shade, anything that we actually need in the application. So you can see here we're applying the different time of day to see what the shadow would be. Again, really important things for construction, really important things for cities who are working on actual data. Then once you've actually got the data produced, it doesn't have to just be a pretty 3D mesh. You can then use that information inside your business intelligence in something like the feature analyzer to start analyzing that data and start analyzing, okay, as I said already, what areas, let me just going to kill that Teams, what areas are, have overgrown networks, what areas have that need to be checked. So being able to run that at sorry, there we go. Being able to run that and see the information at any time. So being able to actually have that in the system. So play that again. So now, yeah, we can see the videos and you can see the workflows in Map Enterprise that you can actually click on. So if someone then analyzes, sees the information, drills into it, and then can take action. So actually not just having the pretty mesh, not just having the data from, in your pretty pictures, but actually being able to visualize and action it inside the system. So in this case, looking at the data as trees, being able to visualize the green areas here are where the trees are overlapping the utility network. And then as you can see there, you can see clearly where those trees are from the imagery, but also being able to auto-generate that from the model, from the system, and then create work and create jobs out of it, which is really useful. That's going to And then, of course, then it's a case of being able to push that information out to a mobile device so that people can actually use it and work from there and start filling in. And we've kind of covered this already, so I'll skip out. So the next part of our 3D solution, one of the features that that are part of what we were showing there in that generation is using AirDAS Imagine to be able to turn these images and points into actionable information to improve your speed and confidence in decision making. So with Imagine, you can connect to comprehensive support for imagery, radar, and vector. It has many built-in sensor models, and it has support for point clouds. It can process hundreds of images and has an intuitive user interface to build and test models, and you can do auto mosaicing and compression, and then you can extract that data out to other formats. And with Imagine, then you can understand change detection, you can build train models, and you can do object recognition through deep learning and other machine algorithms. So again, from that imagery, being able to detect, okay, where are there, what type of buildings there are, is there certain incidents. I was talking to one organization. I think a big thing now is trying to detect where solar farms are popping up, because they have a big, they should have planning permission, they should be approved and everything. So being able to detect that imagery, that these instances using something like Imagine, is really good. And the big power of Imagine is being able to have an a spatial model that you can run. So a primary model that you can actually in there create your model. So exactly what we were doing earlier on, taking the source data, doing an analysis on it, like the tree cutting, being able to figure out where to cut and then generate out. There's a few people on the call I know of FME background, so very similar modeling capabilities that you'd see in FME. We can also be extended using Python so that you can actually even add some more advanced functions. So Spatial Modeler is really a box of tools, a box of Lego that you can then build out your professional applications. And these can be deployable anywhere, so you can run these services wherever the data is, run it on the edge, and then generate your outputs. Some of the operators to remind you of, there are classification operators to extract buildings. We can compute footprint, correct holes, clump, and then do raster output as well. Yeah, and then, yeah, we can initialize. So I will now hand over to Andrew, who will now take you through a little bit more on Imagine.
Okay,
Stop
thanks very
sharing.
much, Kieran. I'll just share my screen 1 second. Oh, hang on. Sorry about that. Okay, we'll just start the slideshow. Yes, I'm just really going to highlight a few things that Kieran mentioned there, especially in around Erdas Imagine. I'll go show you an example of how we can process and analyze some 3D data within Erdas Imagine, and then how we can get some outputs out of that, especially around slope analysis aspect as well, maybe even looking for roof potential for solar panels. But really, just to start off on 3D digital data and just talk through some of the benefits. And I know some of you are from a more of a GIS background, and really just talk through it sort of in that context. But with GIS, mostly when we're looking at GIS, we tend to look at 2D GIS, and obviously the benefits of 3D data allow us to have enhanced visualization, allow us to be able then to have more context of what it is we're looking at, and especially for those non-GIS users, it gives them a little bit more of an idea of what's going on within the data and within the models. You can see here on the left-hand side, we have an image of the Dublin Docklands. This is available on open data. You can download this. You can import it into Erdas Imagine, into FME, into all of your geospatial workflows, and you can use this to model for planning. You can use it to model for like emergency response or disaster management. When you're looking at data like this, where you have maybe windows, you have the number of floors, that can become quite a useful tool for that kind of application. As well, 3D data, we use it for environmental modeling. So more large-scale national data sets, such as like large digital terrain models that the national mapping agencies would have. You'd be able to do watershed analysis with that, so be able to look at where the flow of water is going. That's something big hot topic at the minute, especially in Northern Ireland, with the environmental catastrophe in Lough Neagh. You can also use 3D data for natural resource management as well. So, for example, if you've got a quarry, you may want to do a survey from a UAV or an aerial sensor. You'd be able then to use LiDAR or photogrammetry to be able to calculate the volume of that quarry, or sorry, the lack of volume of the quarry, what's been extracted. And you could do that survey again as much as you want to then be able to calculate the volume of what's been removed each time for the resource management. So there's all kinds of applications that you can have with using 3D digital data compared to just the traditional 2D techniques. With 3D data, it's very, very important to consider your data source. So different applications will require different data sources. So for the likes of a lot of what I was saying earlier there about the flood modeling, you'd be more interested maybe in a digital terrain model, and you'd be interested in that and maybe more of a larger scale. So you'd be potentially looking at an aerial survey or maybe even potentially some satellite imagery acquisition. And you'd be taking those LiDAR photogrammetry outputs and you'd be turning those into a digital terrain model. But if you're interested maybe more so in BIM and building modeling and looking at multi-floor analysis, things like that, you maybe be more interested in some of the smaller scale data acquisition sources, such as UAV, or you may even be looking at maybe some of the more terrestrial data collection sources, such as total stations. And yeah, just to touch again on what I mentioned earlier, different kinds of application require different kinds of data and different kinds of analysis and different scalability. So, for example, as mentioned earlier, BIM, if you're interested in emergency planning, a BIM modeling and collection of data for that is something that you'd be wanting to do. If you're interested in natural resource tracking, power line detection, or volume analysis of vegetation, you maybe be interested in looking at point clouds and doing your analysis on that. And as I mentioned already as well, your viewshed analysis, your flood risk modeling, your hydrology, all of those kind of things can be done using more larger scale terrain models. So this is the point of the slideshow where I'm going to actually just stop sharing for a second. I'm going to exit out the slideshow and open up Erdas Imagine and just show you some of the functionality that we have within that application. Sorry, just 1 second, everybody. Kieran, just double checking. Can you see Erdas Imagine loaded up on screen there?
Yeah, I can. Yeah.
Oh, good. Okay, excellent. So yeah, Kieran's already talked a little bit about Erdas Imagine and some of the new features within the 2023 version. So for those of you who haven't seen it before, Erdas Imagine does sort of look and feel like a lot of the typical GIS tools that you would have. It has ribbons here at the top that allow you to manage your data, look at raster data analysis, vector data analysis. You've got some terrain tools here as well. You also have the links to Google Earth and the Google Earth Cloud, and you can now bring data down from Google Earth into Erdas Imagine, and that will help you with your raster analysis models. And then whenever we actually come into some of the data sets, when you click on the data set, you will see there's some new tools have just opened up because we're looking at a point cloud data set here. This little sample of data is available on Open Data Northern Ireland. It was captured by the Department of Infrastructure as part of the A26 upgrade work. So you can see we've got our point cloud here, and it's been colored. And you can see we've got our RGB highlighted on the point cloud data. So we can see everything's displaying as we expect. We've got our trees are displaying as green, and our buildings are displaying as we expect them to appear within the scene. We can change the size of the points, just depending on the kind of analysis that we want to do. So you can see this is actually them at a single point, or you can make them a little thicker just if you want to get a bit more context. You can also change the scale of the point cloud as well. You can, at the minute, it's actually as real life, but you can extrude that up to 2 and 3 times the scale. And then you can also look at a number of other different ways of coloring the points. So we could look at elevation. And you can see then, as we're going across this scene from the southwest corner up to the northeast, you've got a hill and it's going upwards. So the more red the color, the higher the object or the higher the terrain within the point cloud. And whenever we are working with point clouds, we do have a number of tools that we can use to help process that point cloud. So we can classify the point cloud using this tool here. And we've already carried out a little classification on this point cloud. And the classification has given us a ground classification. So what we can do with this is we can actually get rid of all the other points and just be left with our ground points. And when we're just left with the ground points, what we can then do is we can then take those points, we can export them out as a ground point cloud, and we can then do an interpolation onto that to create our digital terrain model. Now, if you're not interested in your digital terrain model, and you're interested in looking at the objects as well within that, you could then just interpolate everything that's within the scene. I'm just going to go back to the RGB. Okay, it's just looking there. We've got our 2D view here, and we also now can look at this point cloud and interrogate it within a 3D view as well. So I'm just going to zoom in a little bit, and we can now tilt the data to show us a bit more context, and we can see the 3D data and representation above the ground then. Some of the examples Kieran showed earlier where we could see the mesh within the HXDR system. You wouldn't be able to do that with data just like this. What you would also need to do is you would need to supplement that data with data from another source. So potentially from a mobile scanner, you'd be able then to merge those 2 point clouds together using Erdas Imagine. Some of that data as well that we were looking at earlier was also produced from an oblique camera. And that's something I know certainly in Ireland, we've not really had many surveys done like that before, but I know certainly Blue Sky have been looking at that, and Ordnance Survey Ireland are looking at that as well. So there will be more and more of those types of data sets coming onto the market that be able to do you'll be able to do that kind of 3D mesh creation with. Another thing you can see here when we look at the point cloud is we've got our telephone poles, and this is something that a lot of telecommunications companies are very interested in, especially for maintenance. They'll be able to look for sag within these and make sure that they're not actually going to be touching any vegetation. So LiDAR point clouds can be quite useful for that as well, and we can do that kind of analysis here in Erdas Imagine. Another thing we can actually do with Erdas Imagine, I'm just going to close off this window, is we can actually do a profile across the point cloud. So I'll just demonstrate this for you now. So I can draw a line across this scene. And what this will do is this will generate a profile. Oh, you're not going to play ball for me here. I think it might be because I'm sharing and doing a live demo. Nope, it's not working for me. That's okay. We'll just move on, and I can share around. I can include that in the slide deck afterwards, and we can share that around and show you how that works. Okay. And then, as well as the point cloud tools, we also have some analysis tools then whenever we're looking at DTM. So we can take all those points and we can turn those into a digital terrain model. I've just got an example of that here. And we can do that using our terrain preparation tool here within Erdas Imagine. Also within Erdas Imagine, we can look at this as an image here at the minute. So this is a panchromatic image where every pixel is representing height above the ground. We can also look at this as a health shade model, and we can also carry out some further analysis tools, on this to show the aspect of each of the pixels within the image. So here we can see we've got our buildings up in the northeast corner, and we have an aspect of southwest along this ridge of the building. And we can extract all of this information out, especially if we're looking at solar potential analysis. There's certain aspects will work a lot better for solar panel placement. And we can also, as well, calculate slope. And we can look for areas where there's going to be a much larger variation in slope, or where it's going to be a bit more flat. And again, you can incorporate that data along with the aspect data, and you can export all of that out into the viewshed, into your analysis, and you can then incorporate that with vector data to show which buildings would have the best solar potential. I'm just going to go back to the slideshow. Kieran, slideshow back up and running again?
Yep.
Oh, great. Oh, thanks very much. Yeah.
Zoom button.
So yeah, so that's just a very quick little demo of what you can do within Autodesk Imagine and some of the analysis tools you can use. And then just to wrap up from that, some considerations then for the future. So within 3D GIS, there are a lot of challenges, especially around semantics of 3D data, how we display it. There's a lot of data interoperability questions as well that 3D data sets raise. And how we integrate and fuse that with GIS is another big factor. For those of you who were at our webinar back in April on building detection using remote sensing, we actually have created a little application using Map Enterprise that's able to show where changes occurred, where buildings have which land parcels have new buildings. And you can then create a little dashboard out of that. And again, decision makers can come in, they can look at that. And that was incorporating our 3D data and our remote sensing data all out of Autodesk Imagine. And as Kieran mentioned as well, some of the other future considerations, especially you could see with what we were showing in Autodesk Imagine, it was just a very, very small data set. But actually, if you're maybe more interested in working at a national scale, working with digital terrain models and point clouds from much larger areas, they can become quite large file types, and it can become quite chunky to process as well on your PCs. And that's where the Hexagon HXDR comes in very nicely. And that's me. I'll just hand back to Kieran.
Right. Thanks, Andrew. Share screen, and that one, and there we go. Okay, so I'm just going to, thanks Andrew, that's great. I'm going to just cover now. You can see my screen, yeah? Well, we can see my picture.
Yeah, I can, yeah.
Yeah, right. So I'm just going to cover now the FME for digital twin and some of the FME tools very briefly before we wrap up. So for everybody who might be new to FME, FME consists of FME desktop, server, and FME cloud. Form and flow, as they're now known. So form is the desktop and flow is for server. And sorry, with FME, we've unrivaled data support. So, we've always had support for GIS and CAD, but of course we have had for a number of years support for 3D, for point cloud, and also now in the last number of years, also indoor mapping and augmented reality and virtual reality, which I'll talk about today. And actually the latest innovation at the top of this line now is augmented is natural generation modeling. So things like ChatGPT as well are now in the product. So with FME, we have a lot of the operators that Andrew has been showing. So being able to read features, do NDVI calculations, being able to mosaic rasters and bring them together. FME is very good for UAV workflows, so it can do raster resampling, it can move files locally into the cloud, check for corrupt images, check images exist, and do flight path analysis. FME has a number of point cloud transformers, so we can do point cloud density, statistics calculator, raster component, expression validator, and then property extractor. And also FME is very useful for taking in mobile mapping data, so point cloud last data, bringing it through a flow line, and then actually outputting it into different formats and creating features out of it. Again, the power of FME is the amount of features that the data can be extracted to. So if you're an organization who is capturing data or receiving data from contractors, FME is the perfect tool for processing that data and outputting it to whatever format you need. With FME, we can create buildings with symbolizers to create a pseudo 3D effect. So if you don't have the kind of nice, great data you've seen in the first part of the session, we can actually do that, actually build based on a height. Maybe this is part of the address database to actually take a normal footprint and extrude out a building from that. We can do that in FME as well. Big part of FME is the support for indoor mapping. So being able to actually have maps on your phones and have features on those maps. So indoor mapping, what is it and how do we need it? On average, we spend 90% of our time indoors, but almost none of it is mapped. So again, people are now looking at enabling wayfinding to improve the customer experience and then efficiently manage your assets and facilities and infrastructure. So with FME, We can do CAD to IMDF, which is the indoor mapping format. We can take it from geodatabase, from IFC, from the kind of BIM formats and Revit, and also from city GML to indoor GML. So anybody who's looking at inside mapping, indoor mapping, 3D buildings, whatever it is you want to do with them, again, we can handle that inside FME. One example of this is Dublin Airport. So Dublin Airport have done an indoor mapping project. So they took their CAD data, pushed it out into GIS, into a GIS data using database, using FME, and then were able to produce maps in both ArcGIS Online, ArcGIS Indoors, and Apple Maps. So actually being able to provide these full indoor mapping systems. So then you can see the kind of IMDF in action. So when you go to Dublin Airport, you'll see the map, see where you're walking, see what shop is near you, what building is beside you. So again, all driven by FME. So a big part of where we're going because of this growth of sensors, because there's so many more ways to capture information, this is the kind of stuff that we can actually do. With FME, we can also create visualization pipelines. So being able to look at things like this kind of BIM data, being able to visualize that inside FME without conversion, being able to have the immersive view, being able to look at this kind of 3D indoor data, using the kind of workspaces we're looking at here, being able to build out these kind of workspaces. FME also now supports augmented reality. Here's Garrett on the screen, playing with the sphere that was at our recent data event. So as you can see, with these kind of immersive augmented realities, you can then see features either in the field if they're underground, or if you're just in a location, you need to visualize what these things should be in augmented and in 3D, and we can actually do that with FME. So with FME, we have the roles to do everything with data, to bring the information in, and to build these flow lines as well. So this morning you've seen how we can do with the Hexagon solutions, we can actually have automated processes to actually take the data from the sensor and generate 3D objects, point cloud objects, generate data meshes, so to create your digital reality. With Hexagon Airdas Imagine, we can then actually add in, build extra spatial models and flows to do feature extraction, to do classification, to do additional analysis. And then with FME, we can take that data, push it out to whatever format you need it to be in. We can then push it into indoor mapping or outdoor mapping and into whatever systems you actually want to consume your actual information. So no matter where you are on your digital reality or 3D flow, we have the solutions to work with you. And I think that's our content. I don't see any questions. If there's any questions, please throw a couple in and we'll be happy to answer them. We'll give a couple minutes, but if not, I think we'll let you get a few minutes back at your day. Like, thank Andrew for putting together his demo. He took the bullet today doing the live demo. So I usually am the one
It's
taking the
always a
risks.
risk.
Yeah. So well done on that. If you need anything else, if you have any questions, or would like any more information, please feel free to reach out to myself or Andrew or to Tanya, and we'd be happy to give you a bit more in depth. This morning was definitely a bit of a whirlwind tour through all that we can do for 3D and digital reality, but happy to explain a bit more in the future. Okay, I think no, there's no other questions, so I think Tanya will.
Don't see anything coming through there, but we will follow up and send an email out to the attendees with the recording of today's webinar so they can watch it back and then reach out if they have any questions. So thanks, guys.
Perfect. All right. Thanks, everybody. Thanks, Andrew. Everybody has a good day. All right.
Thanks, everyone. Goodbye.
Thank you.
Care.
Bye-bye.
Bye. Bye-bye.